We are living in an age of unprecedented transformation, powered by a technology that is rapidly reshaping our reality. Artificial intelligence is no longer a concept from science fiction. It is the invisible engine of the 21st century. It's the silent co-pilot in scientific discovery, unraveling the complexities of the human genome and predicting the structures of proteins in minutes, a task that once took years. It's the master architect designing sustainable cities and optimizing energy grids for millions. In our daily lives, it translates languages in real time, connecting cultures across continents. It powers the logistics that deliver goods to our doorsteps and the algorithms that help doctors diagnose diseases with astonishing accuracy, often seeing what the human eye might miss. This revolution promises a future of unparalleled efficiency, creativity, and progress. It feels abstract, ethereal, a force that exists somewhere in the cloud. We interact with it through sleek glass screens and simple voice commands, and in return we receive answers, art, and assistance as if by magic. But this digital magic is an illusion. It is not conjured from thin air. Behind every seamless interaction, every generated image, and every complex calculation lies a colossal physical reality. The cloud has a body, and it is made of steel, concrete, and silicon. It lives in sprawling anonymous buildings known as data centers, the factories of the digital age. Inside these fortresses of information, hundreds of thousands of high-performance processors work in unison. They are the computational heart of AI, and they run hot, incredibly hot. The sheer density of computing power required to train a single large language model or to serve millions of user queries simultaneously generates a thermal load equivalent to a small industrial furnace. Managing this intense heat is not just an operational challenge, it is the central, non-negotiable requirement for keeping our digital world online. If the heat is not relentlessly drawn away, the servers will fail and the magic will stop. And so a second parallel infrastructure exists, a vast circulatory system dedicated entirely to cooling. This is where we find the hidden cost, a cost few of us consider when we ask a simple question or generate a piece of text. The most common and cost-effective method for cooling these digital factories on a massive scale is through water, specifically evaporative cooling. In enormous cooling towers, water is pumped to the top and allowed to cascade down, interacting with air force through by giant fans. As a portion of this water evaporates, it carries heat away into the atmosphere, chilling the remaining water, which is then circulated back to absorb more heat from the servers. It's a simple, effective process, mirroring the way our own bodies use sweat to cool down. But the scale is staggering. Every time you send a prompt, you are initiating a chain reaction. Your request, translated into electrical signals, causes processes in a data center, potentially thousands of miles away, to draw power and generate heat. In response, the cooling system kicks in, and somewhere water is consumed. It vanishes into the air as vapor, never to be returned to the local watershed from which it was drawn. We are not talking about small amounts. A single data center can consume millions of liters of fresh water every single day, as much as a small city. And as the demand for AI grows exponentially, so does the thirst of the infrastructure that supports it. This demand is creating a new and critical pressure point on a resource that is already under immense strain. The paradox is that these digital fortresses are often built in the very places where water is most scarce. Arid, sun-drenched regions that offer cheap land and stable climates, but where every drop of water is precious. A silent conflict is emerging in communities around the globe. pitting the insatiable thirst of the digital future against the fundamental needs of agriculture, ecosystems, and local populations. The promise of AI is boundless, but its foundation is built on a finite resource. As we race to build a more intelligent world, we must confront an urgent question. Can we sustain our digital ambitions without draining our planet dry? The true cost of artificial intelligence is not measured in dollars or silicon, but in water. This is the water wars of the digital age. An Eco-Innova-Tech investigation into the hidden environmental footprint of AI and its staggering consumption of our most precious resource, water. In the invisible world of bits and bytes, a revolution is underway. Artificial intelligence, once a concept of science fiction, is now a driving force of our global economy, our culture, and our daily lives. But this digital transformation is not without a profound physical cost. As AI models grow exponentially larger, their computational demands and consequently their energy and water consumption are skyrocketing. Every search query, every generated image, every line of code written by a large language model begins and ends here. Inside the humming climate-controlled corridors of a data center, these are the factories of the 21st century. And like the factories of the Industrial Revolution, they have an insatiable appetite for resources. The core of the problem is a fundamental law of physics. Computation generates heat. The millions of processors working in concert to train a single large AI model produce a thermal load equivalent to a small furnace. To prevent catastrophic failure, this heat must be constantly and efficiently removed. For decades, the industry's go-to solution has been the cooling tower, a technology that relies on the simple principle of evaporation. Water, the lifeblood of our planet, is used to carry waste heat away from the servers and dissipate it into the atmosphere. This process is incredibly effective but also incredibly thirsty. The metric used to measure this is called water usage effectiveness, or WUE, calculated in liters per kilowatt hour. An efficient data center might use less than 1/5 of a liter for every kilowatt hour of energy it consumes. But when you consider that these facilities operate 24 hours a day, 7 days a week, consuming megawatts of power, the numbers become staggering. A single large-scale data center can consume as much water as a small city. To put this into perspective, consider the training process for a single state-of-the-art generative AI model. Recent academic studies estimate that one training run for a model on the scale of GPT-3 can consume millions of liters of fresh, clean water. That's enough to supply hundreds of households with their water needs for an entire year. And this isn't a one-time cost. These models are constantly being trained, fine-tuned, and updated. Each iteration, each improvement adds to this cumulative water debt. The water used for data center cooling isn't just any water, it must be fresh water, often treated to prevent mineral buildup and biological growth within the intricate network of pipes and cooling systems. This means data centers are drawing from the same finite sources of potable water that communities rely on for drinking, for sanitation, and for agriculture. As the AI boom accelerates, we are witnessing the emergence of a new and powerful competitor for this essential and increasingly scarce resource. The conflict is no longer theoretical, it is happening right now in communities around the world. The front lines of this conflict are emerging in regions already facing extreme water stress. In arid places like Arizona, Chile, and Spain, the arrival of massive data centers has ignited a fierce debate. Here, where every drop of water is precious and meticulously allocated, tech giants are now competing directly with farmers, indigenous groups, and residential communities for the same dwindling resource. In Arizona, a state grappling with historic droughts and cuts to its Colorado River water allocation, new data center projects promising jobs and economic growth are being met with local resistance from residents concerned about the future of their water supply. In Chile's Atacama Desert, one of the driest places on Earth, data centers built to serve the region's booming tech and mining industries are placing additional strain on aquifers that are critical for local communities and fragile ecosystems. And in Spain, a country facing its own severe drought and desertification, agricultural communities that have cultivated the land for centuries are now watching as water is diverted to cool the servers of global technology companies. The narrative is the same, a clash between the needs of the digital future and the immediate physical needs of the present. The promise of technological progress is running headfirst into the reality of ecological limits. To understand the scale and complexity of this growing crisis, we travel to these global hotspots. We will investigate the true cost of our digital lives, exploring how the tech industry's relentless thirst for cooling water is fundamentally reshaping local ecosystems, straining agricultural economies and creating new geopolitical fault lines. We will speak with the farmers whose livelihoods are threatened, the community activists fighting to protect their local water sources, and the policymakers caught between promises of economic development and the duty to ensure a sustainable future for their constituents. This is a story of unintended consequences where the pursuit of a virtual world is having profound and often unseen impacts on the physical one. It's a story about power, both electrical and political. It's about who gets to decide how a region's most vital resource is used. As data centers become critical infrastructure on par with power plants and ports, their location and operation are becoming matters of national and international significance. The global distribution of data processing power is beginning to mirror the global distribution of water, creating a new map of technological haves and have-nots, defined not by silicon but by hydrology. But this is also a story of innovation. Faced with mounting public pressure and the physical reality of water scarcity, the industry is in a race to reinvent the data center from the ground up. We meet the engineers and scientists on the front lines of this challenge. In coastal regions, some are pioneering the use of seawater for cooling, a solution that taps into an abundant resource but comes with its own set of engineering and environmental hurdles, such as corrosion and brine discharge. Others are working to integrate data centers into the urban fabric by creating closed-loop systems that use recycled municipal sources like treated wastewater or so-called grey water for cooling. The most revolutionary advances, however, may eliminate the need for water altogether. We'll explore the cutting edge of immersion cooling, a technology where servers are submerged directly in non-conductive dielectric fluids that transfer heat far more efficiently than air. This method not only drastically reduces water and energy use, but could also allow for the capture and reuse of waste heat, potentially warming nearby homes and businesses. From intelligent software that optimizes cooling loads in real time to radical new designs that embrace the local climate instead of fighting it, a new generation of innovators is proving that the future of AI doesn't have to come at the expense of our planet's most vital resource. The challenge is immense, but the search for a sustainable solution has begun. From Microsoft's water-saving facilities in the desert to Google's European green data hubs, a wave of innovation is underway. The pressure to adapt is mounting and the need is urgent. In the halls of government, policymakers are debating how to balance rapid digital progress with the growing demands for resource justice. Meanwhile, environmental activists are demanding greater transparency and accountability for tech's hidden water footprint. And scientists are racing to build the next generation of AI infrastructure that aligns with our planetary limits. But this story isn't about halting technological progress. Instead, it's about consciously guiding it toward a more sustainable and responsible future. The same computational power driving this demand can be turned inward to help solve the very problems it creates. Machine learning models now optimize industrial cooling cycles, predict droughts, and even design new materials for ultra-efficient data centers, creating a circular path to innovation. We stand at a precipice looking out at a world being fundamentally reshaped by an intelligence of our own making. We have journeyed from the deserts of Arizona to the coastlines of Chile, from the farmlands of the Netherlands to the dense urban fabric of Singapore. In each place, the story is the same. The invisible engine of the digital age, the data center, is casting a very visible and very real shadow upon the physical world. The thirst for data has created an insatiable thirst for water, pitting the promise of artificial intelligence against the planet's most essential resource. For decades, the digital realm felt abstract, ethereal. Code was weightless, data was immaterial. But we now understand the profound physical cost of our virtual lives. Every search query, every AI-generated image, every leap forward in machine learning is tethered to a whirring server, a spinning fan, and a cooling system that consumes water on an industrial scale. This has created a new front line in the global struggle for resources. It's a conflict that doesn't play out on battlefields, but in planning commissions, in community town halls, and in the quiet desperation of a farmer watching their well run dry. The voices of protest we've heard from local activists to concerned scientists are not anti-technology. They are a plea for balance, a demand for a future where progress doesn't require the sacrifice of a community's right to water or the health of an ecosystem. The tension is palpable, the global placeless nature of the cloud versus the deeply local place-based reality of a watershed. And for too long, the conversation has been dominated by a narrative of inevitable trade-offs. But the story doesn't have to end there. We are also witnessing the dawn of a new era of innovation, one born from necessity. We've seen the ingenuity of engineers harnessing the cold depths of the sea, the creativity of architects designing data centers that breathe with the outside air, and the foresight of planners integrating facilities with municipal water systems to use grey water and treated effluent. We've seen the radical potential of immersion cooling, which promises to slash water use batteries by nearly eliminating evaporation. And we've seen the elegant logic of heat reuse, where the immense thermal energy generated by computation is captured and repurposed, warming homes, greenhouses, and even fish farms. These are not just technical fixes, they are philosophical shifts. They represent a move away from an extractive linear model of take, use, dispose, and toward a circular, integrated approach. But technology alone is not the answer. True, lasting change will be built on a foundation of transparency and accountability. The era of corporate secrecy around resource consumption is coming to an end. Robust policy, standardized reporting, and third-party audits are the essential tools that empower communities, inform investors, and hold the industry to its promises. It is through this framework of shared knowledge that we can ensure the burdens and benefits of the AI revolution are distributed equitably, not concentrated in the hands of a few, while the costs are borne by the vulnerable. This is the core of environmental justice in the digital age. Which brings us back to the beginning. The future of intelligence depends on more than code. It depends on climate, community, and conservation. It depends on our ability to see the intricate connections between the algorithm and the aquifer, the processor and the protester. The real question isn't how powerful our AI becomes, but how responsibly we let it grow. Responsible growth means choosing locations with an eye toward ecological impact, not just fiber optic access. It means designing systems for maximum efficiency, not just maximum power. And it means operating with a sense of stewardship as a member of a community, not just a node on a network. This is the new frontier of sustainability, where digital meets ecological, and innovation must learn to think like nature. For millennia, natural systems have perfected the art of circularity, efficiency, and resilience. There is no waste in a forest, only nutrients for new life. There is no pollution in a healthy river, only a complex, self-regulating system. For technology to be truly sustainable, it must emulate this wisdom. It must learn to integrate, to adapt, to give back as much as it takes. This is our challenge and our opportunity to build an intelligent future that doesn't just serve humanity, but honors the planet that sustains us all. The next chapter of human history is not just being written in code, it's being written in water. Eco Innovatech, exploring the systems behind sustainability.